Hello. So, today I wanted to talk to you about this article on X-ray diffraction. Now, the very first question that comes to your mind is why X-ray diffraction? So, if you make a list of the greatest experiments in physics, then this experiment of X-ray diffraction has to be on the top. And this was one of the landmark experiments in 20th century physics. It is one of the most basic experimental technique used in crystallography. Now, what is crystallography? Crystallography is the branch of science that deals with the arrangement of atoms. Now, in order to understand what is X-ray diffraction, we need to go through history. So, imagine 17th century. Now, by the word imagine, what I mean to say is in 17th century, people don't know anything about atoms because atom was discovered much later in 19th century when Dalton came up with the atomic model. So, people are still struggling to find out what is inside the material, and by people I mean scientists or physicists, right? And at that time there was this one very important question, that in nature, why do things have regular external shape? For example, if you pick up a stone, then why does this stone have regular external shape? And this was a very fundamental question. Then, to answer this question, two brilliant physicists came together. First one was Kepler and the second one was Hooke. Now, they gave a postulate that there must be something inside a material which they called it as building block, and this building block must be periodically arranged so that the things in nature will get their regular external shape. Now, you see, this was a very vague idea first of all, because what are these building blocks? Not defined. How they are arranged? Not defined. But imagine to come up with this idea of, you can say, building blocks getting periodically arranged inside the atoms in 17th century. That is great. Now we will switch back to 1895, because in 1895 William Röntgen discovered X-ray, and this discovery earned him a Nobel Prize. And you will be amazed that the first Nobel Prize in physics was given to William Röntgen himself because of discovery of X-rays. So let's say somebody comes up to you on the street and asks you who was given the first Nobel Prize in physics. So now you can tell him that William Röntgen got the first Nobel Prize in physics. But he didn't do much research on X-rays, and at that time X-rays were very new, and people didn't know about the nature of X-rays, whether X-rays are waves, whether those are particles, just like light. Light had also very mystery back then, whether light behaves like a particle or it behaves like a wave. Then Einstein came up and then said, oh no, it is not a wave, it is not a particle, light has a dual nature. Just like that, one more question appeared, whether X-rays are waves or whether X-rays are particles. Now, in 1914, a German physicist, Max von Laue, came up with a postulate. Now his postulate is, if crystals are periodic arrangement of atoms and if X-rays are waves, then crystal should diffract X-rays. Now just take a step back and try and understand what is he saying. For in first if he has given the definition of crystal, that crystal are periodic arrangement of atoms. At that time people didn't know what are crystals, so this was very important. And in second if, he gave the definition, he gave the nature of X-rays, and that was also very important at that time. And then he carried out the experiment and it was successful. And this was one of the greatest scientific discovery, that X-rays are waves. Imagine, after a single experiment he had two great results. and he got Nobel Prize for this discovery as well. So, in later, again, one more scientist, Bragg, came up, and what he told that the diffracted X-ray. So basically, whenever the X-ray is incoming on the crystal, then it will diffract. Now, what Bragg said that from today we'll call this diffracted X-ray as reflected ray, and that's it. Just by calling diffraction as reflection, this was his law, and he got Nobel Prize for this. So imagine, just this topic of X-rays have 3 Nobel Prize inside in it. And what was the Bragg's recipe for getting a Nobel Prize? It was basically to call a diffraction as reflection. Now, why it is so important to call diffraction as reflection? Because by viewing these diffracted rays as reflected rays, the analysis, the calculation part becomes very much simpler. And here I want to tell you a quote by Bragg himself. He said that the important thing in science is not so much to obtain new facts as to discover new ways of thinking about them. Now you must be thinking, okay, enough of history, now just tell me what is X-ray diffraction. Okay, so X-ray diffraction is a technique used in material science to determine the crystallographic structure of a material. X-ray diffraction works by irradiating a material with incident X-rays and then measuring the intensities and scattering angles of the X-rays that leave the material. Now, okay, this was very technical, so let me boil it down for you. So first of all, we need to understand that crystals are arrangement of atoms. Now imagine there are crystals in front of you, means there are number of atoms in front of you, and from one angle X-rays are coming on these atoms. Now these X-rays have energy with them, right? So whenever an X-ray is fall on this atom, then this atom will absorb that energy, right? And by atom I mean electrons. Now these electrons cannot hold on to this energy. Up to certain level they can, but after that they have to radiate this energy. Now this electron will radiate this energy in the form of X-rays in all possible directions. So imagine one single electron is radiating energy in all possible directions, right? And now I am talking about a single electron. Now imagine there are number of electrons in a single crystal, and every electron is radiating energy, radiating X-rays in all possible directions. Now consider a single direction. In this direction, all of these radiated X-rays might constructively interfere, and by that I mean that all of these radiated X-rays might add up and prepare a single beam, or they might destructively interfere, means they can cancel each other out. But we are interested in the constructive interference, means all of these X-rays and add up and they perform a single beam, right? And by studying this single beam, we can analyze the atomic structure. We can determine what are the interplanar spacing between the planes. So this is the working of the X-ray diffraction. And on this, Bragg gave his second law, which was 2d sine theta is equal to n lambda, which we have studied in 12th physics, where n is the number of integer, lambda is the wavelength of the beam, d is the interplanar spacing, which is very important for us because it tells at what distance atoms are arranged in a particular manner. So this was all about how X-ray diffraction works, how it goes. Now regarding the application, today X-ray diffraction technique is used in many different sectors, like pharmaceutical industry is there, forensic science is there, geological applications are there, even in microelectronic industries, glass industries and corrosion analysis. Thank you very much.